All right, last problem here, problem 104, page 363. You have a similar assigned problem. You have 103 on the same page assigned. This is about linear and angular speed, and here's the problem. It says this is a disk, and it says the maximum speed of this disk is 7,200 revolutions per second, and its diameter is 12 centimeters. It says find the linear speed, let's talk about that in a moment, at a point that's 5 centimeters from the center. So if this is 12, then the radius is 6. Here's 5, and this thing is spinning. And it's spinning, in fact, at 5,400 revs per minute. And it says let the units of the linear speed be kilometers per hour. So, yikes. What's this all about? So let's come down here, fix a point here, fixed point, okay? And let's assume we've got a ball on the end of a rope that we're swinging in a circular motion like this, okay? Fixed point, we're swinging the ball around in this fashion. So in a time delta t, let's just assume that this swings through theta degrees, theta radians. If that's the case, then theta divided by delta t, we'd want to call that the angular speed. It is the rate at which we subtend through angles. Yeah, different from the linear speed, to be sure. This is the angular speed. It's normally given omega, Greek omega, as the symbol for angular speed. So at the same time that this ball is swinging through a central angle of theta, it's also traveling a distance a distance s. And if this radius is r, then you would want to say that s divided by t is the amount of is the length that this ball travels in the circular arc in a time t. That's the linear speed. And that we generally give the symbol v to. Think of the linear speed as what would happen if at any instant in time, so at delta t, this ball has moved over to this side, and the rope snaps, this ball will shoot off in a line tangent to this circle, and it'll shoot off at a speed v. Yeah. So note that there's a relationship between omega and v, because there's a relationship between s and theta. And in fact, remember that s is equal to r theta. And so if I make that substitution right here, then s of delta t is equal to r theta all over delta t. And oh wait, theta over delta t is equal to omega, and s over delta t we've said is v. So there's the relationship between the angular speed and the linear speeds. So now all we have to do is come up here to the top, and we see that this thing is spinning at 5,400 revs per minute. So omega is equal to 5,400 revs per minute. This problem is mostly about units more than anything else. And R is equal to 5 centimeters. And so omega times R is going to be equal to the linear speed. So the V is equal to R. No, it's equal to R omega. So let's just put it in. Well, it's R omega. So R is 5 centimeters times 5,400 revolutions per minute. Oh, good gosh. All right, so again, what we want is V in kilometers per hour. So here we go. V is equal to 5 centimeters times, 100 centimeters in 1 meter, and 10 to the 1/3 meters in 1 kilometer. Yeah, what I'm doing is this thing I call unit analysis, where you just have to kind of multiply these figures by 1, written in a different way. 1 meter is 100 centimeters, so 1 meter over 100 centimeters is 1 kilometer is 1,000 meters, so 1 kilometer divided by 1,000 meters is 1. So I haven't done anything to this 5, but I have changed its units from centimeters to kilometers. And now I've got revolutions, and I really need to have radians. So let me say I've got 5,400. Each revolution in 1 minute is 2 pi radians. 2 pi radians in 1 revolution. And I don't believe I have room over on this side, so I'm just going to continue and say 1 minute, I've got 60 minutes in 1 hour. So if I can kind of cleverly figure out what these things are, I've got 5 inner, 10 to the 5th. I really used to know how to do that, but if I just do it like that, times 5,400 times 2 pi times 60. And I've got an answer, and I have no idea if it's right. I'm going to write it down anyway. V is equal to 101 point, we'll just say 8 kilometers per hour. I'm going to check that real quick before I sign off. 5, enter, 10,000, 5 divide, 5400 times 2 times pi times 60 times, and I got the same answer twice, so we're going to go with it.